Welcome to Chain of Sounds. In this program we will speak about tree rings, double basses of course, but age and how to find out things about the wood that they are made of. And I'm here together with Associate Professor Johannes Edvardsson, who will guide us through this jungle of tree rings and so forth.
Yeah, thanks a lot, and very welcome to the laboratory of wood anatomy and dendrochronology. So in this laboratory we are working with tree rings. We try to date trees and study also what influenced the trees during their lifetime. So we can use the tree rings both as a dating tool and as a proxy for different environmental or climate related factors. And I'm looking forward to this talk because I'm also a bass player actually, so tree rings and music instruments sounds like a great combination. So it's dendron means tree, chronos means time, and logia means the study of. So basically we use the annual growth rings to develop chronologies.
So how does that connect with geology? I mean, it might be surprising that we are speaking geology.
Yes, that's a very fair question, and if you think about tree ring laboratories, they can be both at geology departments or at archaeology or ecology or forestry departments. So it's a little bit random where they ends up, the tree ring labs, because you have the tree rings and in so many different contexts. But to put it in a geological context, you can say that geological processes happens all the time. It's not just a time scale of millions of years. So, and no matter what you are working with as a geologist, you need a time series, a chronology to understand what is the cause and effect of different processes. So in a geological context, I'm working a lot with trees found in peatlands that could be like 7,000-8,000 years old to make climate and reconstructions from, for example. But it's basically that time scale we're working with the last 10,000 years, and then people that would like go further back in time can use the ice cores or even sedimentary rocks and so on.
Yeah, when we entered the room, you showed us some swamp oak, right?
Yes.
That was, how old was it?
Yeah, the samples over there is from the Bronze Age, so they are roughly 3,300 years old, or it's these oak trees. And they start to be fragile when they dry. And over here we have pine trees from peatlands up in Jämtland that these trees died roughly around 8,000 years ago. And they are amazingly well preserved because they've been in anaerobic conditions. So it's like the bog bodies they found in Denmark, but trees instead. So so it's been they have not been in contact with air for thousands of years.
So how come you started with the dendrochronology interest?
Well, I started here as a student at the department, and I was studying geology, but we have one course about paleoecology, and we visited the tree ring laboratory, the room next door actually, and I felt very familiar immediately with the tree rings, and I found it very interesting, and I simply asked after the day was, do you need some extra hands during the summer? I found it really interesting, and so I started to work during the summer, and then I was working in parallel to my studies, and then my master thesis was about dendrochronology, and then my master thesis turned out to evolve into a PhD project, and since then I've been continued to work with tree rings, but then in many different contexts, so both old subfossil trees from peatlands and fine arts in the nicest museums all over the world. And that's one part that I like a lot, because you find the trees in so many different environments, both the living trees and the dead trees, and so many different contexts also that trees have been used. So you can work with tree rings and one day work with music instruments, one day with paintings, one day with historical buildings, one day with climate reconstructions, and there is so many different topics if you go to a tree ring conference with people presenting what they are doing, so that's really fascinating.
Do you have some other quite exciting experience in the art sector?
Yes, I was working for a period in a project called Jordaens Van Dyck Panel Paintings Project. So they was a research project about these two painters that started their career in working in the Rubens studio. So these three painters have a close connection, and sometimes they might help each other on certain paintings, and so this research project was about how they've been collaborating, if they've been, what relation different paintings might have, and so we were looking at, in total that project been looking at around 300 paintings.
Wow.
And they are then painted on oak panels. So, and the oak usually is from the Baltic region, so they exported oak trees with good quality on the timber from Poland, from Lithuania, to the big harbors in Antwerp and Amsterdam, and then there was panel makers that produced panels, put their signatures on them, and they were quality checked, and then the painter could buy them, and so we could then sometimes analyze the oak timber in different panels and see that, okay, these trees match really good, they must be from the same source area, and in a few cases we could actually see that these two trees are so similar that they must be the same tree in different paintings. So then if the art historians then had an idea that these two portraits should be painted at the same time, and I can show that this plank in this panel and that plank in that panel come from the same tree.
You mentioned when we have had a little pre-talk that you were over in Cambridge, and you had a little problem solving.
Yeah, so that was also one of these panel paintings. So it was a portrait of an old widow. They don't know who it is or why the painting was never finalized. They don't know either if the widow died or couldn't pay, or if the painter died. They can speculate a lot, but the previous owner of the painting claimed that it's Rubens' painting. But then it's at the museum in Cambridge now, and they thought, no, we think it's Van Dyck and not Rubens. So I went there and analyzed the wood in the painting, and I ended up, and I could see that the earliest possible felling date of the tree, I think it was around 1652 or something like that. Yeah. And then the problem was then that Rubens died in 1640, and Van Dyck died in 1641. So both of them were dead when
So
the tree was felled. But then there was an art historian with us, and that had a third idea that I think it might be Jordaens instead. And Jordaens then died in 1678. So if we have these three painters as options for the artist, my dendrodating could at least exclude two of them because they were dead when the tree was felled already.
So is science the primary way to go to decide about the age of a wood, or could we trust the art and music experts in terms of deciding about?
So I think there's a multi-proxy approach you need, so to say, that you need to collect information from many different sources. And I can tell when the tree's felled, and many different artists might be using trees of this same age, of course. So my work is not to tell if it was that person or that one that made a violin, for example, but I can tell when the tree was felled and where it might come from. And
okay, now we are getting to another very interesting part, the tree rings. And Johannes have promised to explain how to find out the age of a piece of wood.
So over here we have a disc from a pine tree from Siberia. It's been very slow growing, and we have the bark, outermost part, and just inside of the bark we have what's called the cambium. So this is where the cell formation happens. So we have the youngest ring is the outermost ring, and the oldest ring is the innermost ring. So with large magnification, this is actually then what the tree rings look like. So we can see several rows of cells, and each ring can be divided in two parts. So we have the bright part, which is the early wood, and the dark part, which is called the late wood. And the cells have different function in the early wood and the late wood. So in the beginning of the growth season, so let's say if we are in South Sweden, the growth season starts maybe in beginning of May, roughly. And then we can see that we have cells with very thin cell walls and quite open cells. And the function of these cells are to transport water and nutrients from the root systems up in the stem. And then the growth continues. So let's say we are May, June, July, August, and then we start then the formation of the late wood starts. And then we can see that we have much thicker cell walls and denser cells. And this part of the ring is mainly to give stability to the stem when the trees continue to grow. And we can see that it's also large density variations between the early wood and the late wood. And then we have a quite sharp boundary. So this is when the dormant season starts then. So then the cells formation stops maybe during September, and then the tree is in the dormant season until May the next year, and then the same procedure starts once again with the next ring.
But there's quite a big difference between the left year and the mid-year.
Yes, so we have a wide ring, so this was probably a favorable year, and we have a narrow ring, so a tougher year for the tree. And this specific tree has been growing in a quite dry region, so it's been temperature that's been the main factor influencing the growth of this pine tree. So this is probably colder spring this year compared to this year. But this is not the best piece of wood if you would like to build a music instrument, because you can see it's quite large variations in the ring width that might affect the soundboard in the so the vibrations, some maybe not even in the wood. So you would like to... Yeah.
We are looking for even rings?
Yes.
Tight rings?
Yes.
Okay.
And usually also low density. So we want to have thinner late wood. So we might have a piece of wood that look more like this would probably be better for a music instrument. So this is also pine tree, actually growing in the same region as the previous one, but in a much wetter conditions. So it's been the growth been limited by that it has been too wet for the tree. But here we can see some more even ring width, and we can see very thin late wood also in the tree rings. So this is probably better quality for building a soundboard, this tree compared to the previous one. And if you would like to find a really good fir trees for building a soundboard, some of the classic locations are like in the Dolomites or in the Alps, often in north-facing slopes, and altitudes maybe around 1800 to 1900 meters above the sea level. Then you usually have very relatively wide, narrow rings, and also narrow late wood in the tree rings, and then relatively even growth also on the north slopes often.
So then we have bigger chances to produce an even good sounding soundboard.
Yes.
Okay.
So that's what we would look for in this case. This is also the surface so that we prefer to work with as a dendrochronologist, because if we have this surface, we can see the ring boundary is very clear. We can measure the ring width. We can also measure different cell properties like the cell wall thickness, the cell areas. We can also split the tree ring in early wood and late wood, so we can measure a lot of different parameters if we have this surface. However, when we're working with the soundboard and music instruments, one of the problems might be that instead of having this surface to analyze, we usually have this surface to analyze. So the tree's been splitted in this direction to get the wood for the soundboards. So it makes it more challenging to measure the ring width. And for some tree species it doesn't work. But for fir and for pine trees and spruce it works. Coniferous trees it works fine, but for many deciduous trees it would be impossible to measure the rings on this surface. Mm-hmm. But luckily it works quite fine with spruce trees, since that's the most common tree species in the soundboard.
Yeah.
So the basic procedure then measuring the rings is actually just to find the ring boundary here, and then we have this measuring table connected to a computer with a specific tree ring software. So I can it measure how much this board moves, and each time I pass a ring boundary I will press the button on the mouse, and it will measure how much the table has been moving, and that's equal to the ring width. So that's the most common way to measure the ring width. But of course, a large double bass would not fit here. So in that case,
Not today, no.
so in that case, I would instead make a photo documentation with a macro lens and take overlapping photos and then put them together. Then I have also software where I can calibrate the images and then do the measurements on photos.
All right. Yeah.
And another non-invasive method that would be possible for music instrument is of course also then CT scanning. That then we can actually, in the CT scan, we can actually, instead of looking at this surface, we can of course move around the object until we find the surface we would like to analyze.
Okay.
So there's some benefits with working with a CT scanned images, for example. As long as we can see the rings clearly, at least we can analyze them in different ways. So then the question is if we should give this violin a try, if we can measure the rings and see.
Sure.
Yeah.
That would be nice to see.
So I actually had a couple of violins at home, and this one has not been handled with care. It's been up on the wall for decades and in pretty bad condition. But I think it's the oldest violin I have at home.
Okay.
At first. And also the varnish is quite bright in the color, so we can see the contrasts quite clear between the early wood and the late wood, even if we then have this surface instead of this upper surface, which we have over here, but we can't really see the rings clearly on the surface without making some invasive treatment of the material, and that is of course something we would like to avoid on a music instrument.
Yes, but we can still, it's the same method, so we just pretend it's a double bass. So
yes,
go ahead.
And it will be quicker, it will be fewer rings to analyze also.
Yes.
So let's see if we can adjust the measuring table so we can see the rings. So it's not as good surface as we could see before, because now that the cells, instead of seeing the cells as straws from above, we see them cut from upside and downwards. So we can't see the cells really clearly, but we can see what's the early wood and the late wood. And usually the soundboard is like one piece that has been split into two pieces, and then we have a joint in the middle where the two parts are put together, and it looks like we have a growth direction with the youngest rings towards the center and the oldest ring towards the outer part of this violin. So we should then try to see if we can find the joint. It's not that easy to see actually.
A few moments later.
So basically what I'm doing then, we have this software over here. So we have the project chain of sounds here.
Yeah.
And violin number 1. So now I can start and then move to the first ring boundary. So this first ring is then 1.17 millimeters wide. And then I continue to the next ring boundary, 2.22 millimeters wide. and then the next 2.45 millimeters wide. So even if it's a relatively even growth at start, we can see that we rarely find two rings in a row that has the same width. It's almost always variations. And over here we have a kind of a blurry ring. I would guess there is something in there, but it's, so then we can move a little bit upwards and down. Yeah, I think it's a ring, even if it's difficult. This is one reason also why we usually measure the same tree or sample a couple of times, also in different directions and on different parts, so we can see if we do the same interpretation each time. So that's a way also to test yourself and also test if you can trust in the tree, because there are phenomena called missing rings. So sometimes if it's really harsh condition during 1 year, many tree species can actually maybe not form a ring a specific year, and then you have a missing ring, and there are also false rings to make it even more complicated. So that's when during the growth season suddenly something happens, so the growth slows down and then it speeds up again. Then it could look like a double ring actually. It's not a good perfect surface, but it's at least good enough to do the measurements.
Yes.
So this violin, I've been trying to get some knowledge about the story, and as far as I know, it's my mother's grandmother's violin.
Okay.
So, but that's all the information I have. And then we have this black lines, of course, and they are, I think there is a ring.
They are called purfling.
Purfling, okay.
Purfling is the instrument making name, yeah.
Okay, so that's a new word for me.
Yeah, it's the reason is that it helps the wood not to crack in the outside.
Okay, yeah.
It keeps.
So it's not just
For show.
no. Okay.
No.
Okay, so now I think we've reached the
Yeah.
outermost part of the violin, and then we have a growth pattern of the tree over here with, we can see some variations, and that there are not two rings in a row actually that has the same ring width.
No.
And in this measurement I found 64 rings, and I actually, before you arrived, I measured it twice also, so just to have some measurements to compare with, then make a process called cross-dating. So this is a statistic and visual comparison then between different curves. Let's see, so these are my first two measurements, so one in this direction and one in the other direction. And we can see it's two almost identical curves. So now we have created one 69-year long tree ring curve from this violin, and we can start comparing this pattern with some of the classic violin chronologies from the Alps. So each wiggly curve here is one reference chronology, and they start, most of them starts in the 1970s something and goes back to the 1500s, but one of them goes all the way back to 1300s. So
Wow.
we have a few really long chronologies here. So let's then compare do this kind of cross-dating once again. So we have this first sample and we compare it with these reference chronologies and press cross-date. This position is the first suggestion from the with the first reference chronology, and it tells that the best suggestion is that the outermost youngest ring would be 1655, and then it gives a couple of different the 5 best suggestions.
Yeah.
But it's no statistics that I would trust. But it's a lot of places where the two curves mismatch. We go from 1655 to 1954. It doesn't look like it's a spruce tree from the Alps or the Dolomites we have in this violin.
No.
A different setup of chronologies between the 1400s and present day. Looks like there's one undated also. That's there for some reason, but so we can try with these, and these are all from spruce chronologies from Sweden and Finland instead.
Okay.
So we can give it a test if it could be a Scandinavian instrument. So once again, the first suggestion, I don't trust, and then we have one chronology from Dalarna. It gives a little bit better, 1841, but still nothing I would trust. Actually, here we have something that might be interesting, and it also looks good, and 3 stars. That it means that it's a 99.9% significance. We can see this narrow ring here, it would be 1733. It looks pretty similar, and they actually moves up and down quite similar. So it's definitely the best match so far. So at least we have one kind of outstanding match that has been, and we get the same match also 1739 from 2 independently developed chronologies. So I would say this is something that I would continue to work on. The youngest ring on this violin is 1739. It's older than I expected, but of course it can be reused wood, and it also gives a suggestion from a spruce chronology from the Gothenburg area. I have at least an idea now, and I would like to continue them to maybe try to correlate this with timber from along the large rivers that might end up in the Gothenburg area, if it's imported timber in Gothenburg. But this is the basic procedure, like when we start measuring the rings, matching our own measurements until we feel satisfied with the data series from the object, and then we can start comparing the object to either other objects or these kind of reference chronologies then that has been built up from sometimes hundreds of different wood objects. Before I would deliver a report on this violin, I would then continue
You have to let us know in case you continue the work and find.
I'm a little bit.
It would be nice to
curious now because it's maybe 100 years older than I would guess.
But let's speculate a little bit about the person who built this violin. Maybe found a stash of timber or wood that has been there for 50 or 100 years.
Yes.
And this one is made in the beginning of 1800 somewhere, and then all of a sudden this could be it.
it makes sense then.
Yeah.
Yes.
I'm so happy that you let us come in here in this laboratory. It's not very fancy, but it's very exciting, because when you turn around and as you see, this room is vibrating of history. Well, Johannes, thanks for having us. It's such a pleasure, and thanks for taking your time.
Yeah. Thanks
And,
a lot. It's
Chain of Sounds will continue, and we will also looking forward to maybe we can follow up on that violin. That will be our sample violin for now.
yes. If I can convince myself that 1739 is the correct age, I will let you know.
Okay, thank you. See you later.